Today, I'll be showing you how to perform a Pi foundation design in Protastructure with the help of PileSoft software. Now, before we begin, most of you don't know how to design Pi foundation from the pool we ran on our Ekidel WhatsApp platform. Most of the engineers were choosing the wrong options. That shows that they don't know how to design Pi foundation in this software Protastructure. Yes, designing Pi foundation in general is very complicated and it's very complex. Most people don't know how to design a Pi foundation, and even if they know, they might choose to skip some things and all that, and knowing that different softwares has different approach, but which will still lead to the perfect design. So in this software Protastructure, most people tend to find it difficult in designing Pi foundation. That's because this software tends to perform what? Over design of your Pi or of your Pis and the number of Pis and all that. So with that gives them issue. Not really that this software performs over design, but because the people using the software does not give the right inputs, and knowing that there are so many things you are going to input before you can now perform your Pi foundation design perfectly in any software. Now I'm using the Protastructure software as a case study. Now everything I'll do today will be focused on the software Protastructure and all that. So knowing here on Ekidel that we focus more on this software Protastructure and all that, that is why you see that all our designs and everything we do is in line with the software Protastructure and all that. So on today's class, I'll be showing you now how to now perform a seamless Pi foundation design, very easy, with the software Protastructure in line with PileSoft. Okay, that's fine. Let's begin now. Hello, welcome to Ekidel, where I will train future civil and structural engineering. My name is Justice Nwaka and I am your instructor. Now, before we begin, if you have not yet subscribed to our channel and you are new on Ekidel, I would advise you subscribe to our channel so that you don't miss our next video when we'll be designing the Pi itself. Okay, that's fine. And if you are an old subscriber, I would like you to join the Ekidel Premium video channel. Okay, that's fine. Then also give this video a thumbs up so that we can and this video can also go viral here on YouTube. Thank you. So right now, to now begin the Pi foundation design in Protastructure, the first thing you do is to make some settings. Okay, that is the basic steps you are meant to do to perform some settings, and that settings you are going to get that from this place here that says the settings center. So from this place now, you just click on that place and then click on foundation, and from there you will then see the list of three options. Then click on the place that says what? Pi caps. Okay, knowing that Pi foundation is divided into three stages. Pi foundation design is divided into three stages. The first is the Pi cap design, second is the Pi design itself, and the next one is now the connecting beams. So you can see that it has three different design categories which you have to perform. So the first one now we are doing right now is the Pi cap design. Most people think that Pi cap design is very easy because they just see the input, but at the end I have seen most videos here on YouTube, they are doing rubbish when it comes to Pi cap design or Pi foundation design using this software. So I'm here to show you the right way to design a Pi foundation, and because the right way is quite complex, and since our mission here is to carry along the younger engineers, we are introducing a new software that works hand in hand with Protastructure, and that software is called PileSoft. So we are going to work hand in hand with PileSoft, and with the help of PileSoft you will be able to see how easy and simple it is to design a Pi foundation on this software Protastructure, because there on the PileSoft you are going to input your Pi soil report data, which contains the safe working load, which contains the soil bearing capacities, and every other stuff you are going to see on the Pi cap report. Okay, on the Pi foundation design report. Okay, that's fine. So with this now, once you have come to this setting center here, the next thing we'll do right now is to now begin to impute our values. Now imputing your values, now this is where the confusion comes into play, because most people don't know how to actually get these values. I can see that this one says ultimate compression capacity. Most people don't even know what it means, and these other ones too, and so many values that you are meant to impute here. So with the help of PileSoft, I'll be able to show you how to impute these values very easy and accurate. Okay, that's fine. So that takes me now to the software called PileSoft. So on this software now called PileSoft, as you can see, PileSoft version 7. The previous version was version 6. Now this is version 7 on that, and it is being designed by developed by a company called GeoExperts. Okay, so GeoExperts developed this software called PileSoft and all that. Now you can see that on this PileSoft, basically this PileSoft works hand in hand with Protastructure software. So it is hard to design Pi Foundation with only Protastructure software, but with the help of PileSoft, it will be very easy for you to design Pi Foundation accurately on the software Protastructure. Okay, now you will be able to see me how I'll carry that out now. So on this place now, which is the PileSoft, you can see that the PileSoft has different options that you are meant to impute, and these options, these values here, you are going to get it from your soil reports. Okay, or from your from your Pi Foundation soil report, which I will show you just now, because I have a sample which we are going to work with, okay, to get our values imputed here. Now this building you are seeing here is basically a live design. It's a live project in Lagos, Nigeria. I know that this building here, as you can see, is located in Lagos, Nigeria, and currently it is under construction because we finished the design of this of this building not too long, 2 months ago, and all that. So it's currently under construction and all that. So with that, with this, we believe it will be good for us to use to train our engineers here on Ekidel here and all that. So with this now, let's now begin the design of the Pi Foundation and all that. Okay, so basically right now on my screen, what you're seeing right now on my screen is the soil investigation, which is the soil report that was done on the site where the building you just saw is to be built. Okay, so with this now, you can see that the first the first test that was done on a shallow foundation, as you can see it here. But based on that, it was discovered that shallow foundation will not be able to carry the weight of the structure or carry the structure to a suitable soil strata, having in mind that the net allowable bearing capacity, as you can see here, is 30 to 40 kilonewton per meter. Sorry, 30.62 to 42.94 kilonewton per meter square. So with that, it was impossible to use a shallow foundation for that. Although if basically we had to use a shallow foundation, we would have used a slab raft for that. But that, after judging everything, we discovered that the best is to be done with a deep foundation, which is a Pi Foundation. And then we now requested for them to perform a new soil investigation and soil test based on Pi Foundation, knowing that the way you do your soil test on shallow foundation is different from the way you do soil test on a deep foundation. Okay, so right now you can now see that this is now the deep foundation soil report, and on this deep foundation soil report they focused on Pi Foundation test. Okay, and all that, and this was on both Pis, and the first they did was to do the test on 9 meters below ground level, and then they move on to 24 meters below ground level. Now basically, in reality, the reason why they did these two tests of different length of pies, or depth of pies, is because basically they have in mind that we are going to use different depths, because on this building you are seeing, most parts of the structure can be able to carry or go to 9 meters, while some parts can go to 24 meters. Okay, yeah, we have done building on that where it has different depths and all that, where the pie depths are different. They have some of 12 meters and some 30 meters. But just for the sake of those design, we are going to focus on the 24 meters. Okay, but in reality, what we did on the design was to do two designs of pie. One was for 9 meters and the other was for 24 meters. So from the lift, let me just show you right now. So from the lift here backward, we used a 9 meter, and from the lift going forward here, we used 24 meters. So that was what we did on the actual design. But for the sake of this design here, for the sake of this video and then training, I'll be using only 24 meters. But regardless the one I use, know that it is the same steps. Okay, that's fine. So having this now in place here, knowing that we have all our parameters that we want to use for our pie foundation design, beginning from the pie diameter, as you can see, we have a 400, 450, sorry, up to 800, and then the safe working load for both pies at 24 meters below ground, and for each of the pie diameter has their own separate safe working load, and also the total settlement based on the pie diameter. You can see that. I know that although it's very minimal, the maximum here for settlement is 19 millimeter, which is very small. Okay, know that. Then you can also see that we also have other values here which we're going to use for the design of our pie foundation. And then if we then go down below here, you can see that actually the both pie was done at 26.5 meters. As you can see that, you can see the different soil layers that was encountered and the depth and all that. This one we are going to use it when we are designing for the pie design itself. That's when we are going to use this area here. But for the pie cap first, what we need for the pie cap design, knowing that pie foundation is subdivided into 3 different categories, which is what the pie cap design, the pie design, and the connecting beams. Okay, which you're going to connect all the pie caps together to bring what stability of the pie cap. Okay, that's fine. So with this now, let's now go on to displacement. So we are going to use these values we have here now and then impute into PileSoft, and then from the PileSoft we now generate all the values that we are meant to go and impute into the Stonebridge, into the Protastructure software. Okay, that's fine then. So sharing my screen now into like this, where we have our soil report here based on the pie foundation design soil investigation, and then we then have the PileSoft here, knowing that from the beginning I think that we are going to extract all the values that we have on our soil report or investigation into the PileSoft software for the PileSoft now to now generate all the values that we are going to use to now design our pie cap or pie in the software Protastructure. Okay, so right now let's now begin to now extract all the values that we have here on the soil investigation into the PileSoft. So with this now, the first thing that we have here on this PileSoft here is to do what? Is to tell what the type of what shaft. Shaft simply means the shape of the pie. Now pie can either be square or rectangular, but basically the most common type of shape of pie is what? Circular. Okay, so if you click on this place now, you can be able to choose any one you want to use. You can see that you can be able to choose either circular or what, or rectangle or square pie. Okay, but the one that is more common is what? square pile. That's because it is easier to drive into the ground. Okay, so we are going to choose what? Circular pile. Okay, now on this other one that says what? Penetration. Now on this penetration right now, this simply means the amount at which the pie penetrates into the pie caps. Okay, so let me assume that this is a pie cap now. Now this, my finger here, is a pie. Now imagine that this pie now penetrates into the pie cap. Okay, because why? It has to penetrate because the reinforcement from the pie is meant to lap into the pie cap. So that is why there must be a penetration. So it is telling you now the amount of penetration. So basically the amount of penetration varies from 75 millimeter to 100 millimeter. As you can see that the PileSoft here is already giving you a note that the height of penetration of pie into the pie cap can either be what? Be 75 or 100. Okay, but the most common one that is used is what? 75. So I would advise you leave it here as what? 75. Else you can choose at maximum 100. Okay, and then continue. Okay, but first I would like you to leave it at what? 75, because that is the most what? Common. Okay, now on this other one that says now the pie diameter. On this pie diameter, if you check on the note that the PileSoft is given to you, it is said that the pie diameter of 300, 350, 450 and 600 are commonly used for what? For your building. But you can get your pie diameter from your geotechnical what? Reports. Now that takes us now to what? To our report here, to see if our report has what? The pie diameter. And luckily enough, you can see that we have our pie diameter here from the soil report. Okay, that's fine. So from the soil report now, you can see that we have our pie diameter here. And first, this is an 8-story building, and then I want to use 600 or 450 for my pie diameter. Okay, as you can see, we have 400, we have 450, we have 500, 600, 800 and so on and so forth. Okay, that's fine. But when you are designing for your pie, you have to consider the kind of machine, or the kind of machine that is available in your city or in your country, because basically they have several types of machine based on the pie diameter. Okay, I know that. So you have to consider the type that they have in your city or in your country, so that it will be easier for you to get the machine that will be able to drive the pie into the ground. Okay, so basically the most common machine sizes that drives pie diameter is 450 and 600. Okay, so basically I would advise you choose your pie diameter with 450 or 600, or better still, confirm the type of machine or the type of machine that is available in your city and the size of pie diameter that machine can drive in to the ground. Okay, so now basically in Nigeria, Lagos precisely, this basically uses we have common machine to be 450 or 600. In countries like Canada, where I am currently, we have up to 1000 diameter pie, and the machine can be able to pie that diameter, although it's bigger. So the bigger the diameter, the bigger the machine that is coming to piling that diameter of pie. Okay, that's fine. So with this now, I'll start with what? 450. So with this, we then go here and impute our pie diameter to be what? 450. That's fine. So knowing this now, the next thing now is to impute what? The pie length. And on our pie length here, knowing that if you go to this place here, you can see that the pie length is already showing here. Now this pie length now, basically you get your pie length from your soil report, basically, because where they find a suitable soil strata is where you're going to end your pie, or that will be your beginning point of your pie length. So if maybe they find a stable soil strata at 24 meters, then you can now begin to design your pie for the structure on that 24 meters. Now, if 24 meters is not able to carry the load of the structure, you can go beyond, but you must not go below what you have here. Okay, as you can see that we have 24 meters here for the safe working load, and all that. You cannot go and use 19 meters. It will fail. All right, it will fail. But we can go beyond 24 meters. Okay, and all that. Okay, that's fine. So right now we will then go, except you find a rock. If you find a rock at 24 meters, you cannot go beyond that, because no machine, no pile machine can penetrate through a rock. Okay, and finding a rock is already a stable soil strata already to carry for you to end your pile. Okay, that's fine. So with this now, we then take our pile length to be what? 24 meters. So we come now here and then put what? 24 meters. Okay, 24 meters, that's fine. Then we then go over to what? To this place now that says what? Column load. Now this column load will be gotten, we are going to get it from the Protastructure, where we did the building modeling and the building design. That's where we are going to get the column load. But let's leave that for now first and check out for other ones that we are going to extract from this soil report, so that once we close the soil report, we then move on to now go and take the values of the column loads and everything that we need to put from the software Protastructure into this place. Okay, that's fine. So with this now, let's now move into what? The safe working load. Okay, now the safe working load now is simply, you can see it here from the soil report. It's getting from the soil report. Okay, you can see that since we chose 450 as our pile diameter, you will have to choose also the safe working load in line with the pile diameter you are choosing. Okay, so where the safe working load now for the pile diameter of 450 is what? 740.1. so you can see it here. Yeah, I was actually working on that. That's why you are seeing 740 here. But let me assume that we are using 600. I would have come down and put the safe working load of what? 1154.9, correct? Okay, 0.9. Can see that? But right now the safe working load for 450 diameter depth, which you have chose here, is what? 740.1. so we'll come here and put 740.1. that's fine. Okay, then now this one that says pile direction, we are going to get this from the Protastructure. It simply means how you want to change your pile direction. As you can see right now, it is appearing what? Horizontally. If we change to direction 2 right now, it will turn what? Vertically. But we will get that from Protastructure if we see that there is no much space between two piles. Okay, or between two pile cap, we can then choose to change we can then choose to change how our pile cap is to be what? Arranged. All right, I know that's fine. So this now talks about what? The column type. Okay, now we will get this also from our model, because we have to know the kind of column we are designing each pile for. Okay, so right now you can see that we have square, rectangular, and this. Okay, so then we move on to now just to pick up what we're going to use for what we're going to get from this place, from the soil report. Now on this place, you can see that here it says that the multiplying factor between piles. Okay, this actually talks about the spacing between piles. Now you can see that the PileSoft is telling you that basically the minimum factor can either factor can either be 2.5 or 3.0, but please check your soil report for the actual factor stipulated. Okay, so we then go right now and you can see it here that the factor of safety is 2.5. But if you then go here now for the pile grouping, which is the pile spacing, you see that is spacing of 3 to 3.5 times for pile diameter. Okay, so what this means is that we are going to apply what here? The spacing here for the pile, for the factor to be what? 3. But basically now listen, from experience, it has been seen that if you apply any value more than 2.5, that your pile cap tends to fail. It tends to fail. So our advice, you keep yourself 2.5 or below 3.0. okay, now here you're seeing that we should use 3.0 or 3.5, but if we apply this now, it will make our pie cap to get bigger in dimension, and certainly it will fail. So with that, I would advise you stick yourself to 2.5. that is the standard. Okay, so with this now, the next thing is saying that is your pie cap resting directly on the soil. Yes, you can see that now it has two options that says what, yes or no. Now when your pie cap is resting directly on the soil, it has a different approach to do what, to check out for the distance or phase between the pie and the pie cap. And when your pie cap is not resting on the ground, it also has a different approach. I have said that on my previous video on PileSoft, so you can go and check out that video. Was about 2 hours, so go and watch that, and then you'll be able to know how this is actually done. But I would advise that you always say yes, that your pie cap is resting on the ground, except that place has a waterlogging that you tend to raise your pie cap above the ground, except that. But apart from that, it is actually good for pie cap to rest directly on the ground. It helps, the soil itself helps to carry the weight of the pie cap, okay, and help to relieve the weight of the pie cap from the pie itself. Okay, so right now we then move on to the use distance to face, short end and long direction. Now you can see that this actually is being gotten from this place. Whatever thing you pick here will change the value here. For example, if I said no, my pie cap is not resting on the ground, if I pick no now, you can see that here will change automatically. It will change and give you just one value. But if I say yes, it gives me different values, 3 different values for me to choose. So you can use any of the values here and it will work out perfectly. Okay, then this place now that says what, that says measure the spacing between pies. This is where I love PileSoft a lot. Most softwares like StartPro, eTabs and other softwares does not give you warning when your pie foundation is failing based on spacing, but PileSoft will tell you when your pie foundation is failing, and you are to impute this value when you are done designing your pie cap. You then come and then begin to measure the distance between each pies. For example, from here to here, or from this pie to a different pie cap. Now when you measure that, you then come and impute the value here. If the distance between this pie to a different pie cap is too close, is not to standard to what the code says, either BS code, Euro code or American code, then you will see that the PileSoft here will show you warning. For example, if I take that this distance now is, let me say 850 or 800, or let me say 860, anyone, you will see that it is now showing me a warning. It says pie spacing fails, and when a pie spacing fails, basically you are not going to see it during design. Also during the construction you won't be able to see it, but the effect will be directly on inside the ground. And what will happen, look at what the PileSoft is saying. It says pie spacing between pies is too close. Pies will crack inside the ground during the construction. So you can see that it will fail inside the ground. You have cracks, and because you can't see through the ground, you will not know what is happening there. And it is after you are done with your construction, the building is set and everything to be launched, before you know, during the usage of that building, since your pies are cracked inside the ground due to that the spacings are too close, then you will see that you'll be having failures. The building will just collapse, not because your design of pie is not correct, but because the pies are too close to each other. So what happened when they are piling this one, after they are done piling this one, casted this one here, during the piling of this one, because they are too close to each other, the soil tends to do what, bulge out, and begin to hit on this one that is already what casted. And because of the pressure from the machine, from the piling machine, and the soil is also reacting to the same pressure that is coming from the piling machine, which the soil is also exerting the pressure on the already existing pile that you already casted. So since it is too close and the pressure is much, it will have to crack this other one here, and that is what this PileSoft is saying. Okay, so with this, you must make sure that on every account that this place, let me just say, is showing what is showing is showing okay here, is showing okay here, and that will show okay here. Pipe spacing must show okay when you have measured during the design. No, I will show you that. Okay, now this is that one that says what concrete cover. Let's now go. We can get that from the, yeah, you can see that they said that what that the cover to reinforcement in order of 50, okay, should be used to prevent what, to prevent attack of salt water. Yes, that's because this area or the region where this building is to be sited has what, saline water. Okay, that's fine. That's the water around the area is what, saline. That causes the groundwater to be what, saline. Okay, that's fine. So you can see that it gives us what, 50. Okay, but when it comes to concrete cover and when it comes to ground, actually to foundation, you can use minimum of 50 and maximum of what, 100. Like US code takes what, 75 as their minimum. Okay, so basically our advice when it comes to pipe foundation, you use 75 as your minimum. Okay, but you can still use 50. It is nice. Most people tend to use 40, but that's too bad. So you can use 50. We can use 50 as it's easier from the soil reports, but our advice, you use 75 if it's for a redesign you're doing. Okay, but let me just follow what the what the report here says, what, 50. Okay, that's fine. So with this now, we have taken all the values from the soil test into the PileSoft. So what we are not taking right now is the column load, which you're going to get from the software Protastructure, and then the column type or the shape of the column. Okay, that's fine. So let's now go and look at for what we have on the column load, okay, from the software, okay, and the column we are going to design for its pile cap. Okay, that's fine. Now, before we go and take our column load, you can see that there are some settings we are meant to impute before this time on this setting center which we opened before on those place, and this is actually the settings that gets most people confused. Okay, so right now, since we have already imputed some values on that PileSoft, we are now going to import those values now into this Protastructure settings for pile foundation design. Okay, so right now, let's now go and open the PileSoft software to now begin to impute the values that we have taken, okay, from that place. Okay, so on this place now, seeing the PileSoft now, and we have already gotten all the values that we need for now currently. Now let's now, before we impute this our column, because this column load will be gotten from a different interface, not this interface here. So let's now go and do what? First of all, get our design data to get the values that we are going to impute here, because since we have already entered all the values from the soil report, especially the safe working load and all other things, we can be able to get some values here even if we don't have the column load yet. All the values that are to be imputed here, we can get it directly from there. Okay, that's fine. Okay, so but just to be fast, actually, let's just get our column load first, and then just to make it more easier for you to understand, let's get our column load for the column we are going to design its pile cap for. So with this now, I'll then go back to here, cancel here first, and then let's now get our column load. But that will take us now for me to delete all the pile caps which I've already designed, for you to see it now, to now how I'll now perform it very with you here. Now we then have a plain structure here without our pi foundation. So let's now begin to design for our pi. So that takes us now to story 0. So you must be on your story 0, knowing that story 0 is the place where you design for your what? For your foundation. Okay, that's fine. So with that now, let's now pick any of the columns to now design for our pi cap. Okay, but before then, I will have to go and do what? Activate my what? My grid lines and all that. Okay, so I'll activate my grid line now, and then also activate my my text. Okay, I will then click on my text now. Okay, that's fine. And by doing this now, I will then move on to the place. Okay, so with this now, let's now pick any of the column. We can choose any of the columns at all to begin our what? Our design for the pi cap. Okay, we can choose this one, or okay, let me just choose this other one here. So with this now, I will then click on this column here. All right, right click here. Okay, and then come here and then click on what? Insert pi cap. Now this first stage which I'm doing right now, the only reason I'm doing this is to pick up the column load. At least let's have a column load before we can now generate our what values from the PileSoft, which we'll use to design for what? For the pi cap here. Okay, that's fine. So as you can see, because no values has been imputed, you can see that this software Protastructure is given a wrong design. But let's go and look at for our column load. So looking at this now, as you can see that the column load here is what? This is the maximum, which is what? 2649.2. But this is actually the actual axial load on the column, which is the column load on its own. But by the time you add the shear force on X direction and Y direction and everything, you then get the summation of your column load. So we are going to use this other one here that says 2649.2, okay, as our column load. So this now takes us now back to PileSoft, knowing that we have now gotten what? Our column load for just this column alone. And the shape of this column, as you can see here, is rectangular. Okay, rectangular. Okay, that's fine. So with this now, let's now move on to, let's now close this now, because we now have a column load, at least the one we are going to use first to design for this particular pi cap on this column alone, not for the whole columns. Okay, just for this column here alone. Okay, so right now this is 2649.2. okay, 2649.2. get that done. Okay, so I'll then come now and then move on to the PileSoft here. Okay, so on the PileSoft now, we will then come here and then impute what? The value that we have, which is what? 2649.2 on the column load, 264949 point what? 0.2. okay, is it? Yes, that's true. 2649.2. so this is actually the column load now. Okay, so once you have now imputed this value here, which is your column load, and we have already done everything here from the soil report and everything, and then we have known that the type of column that we have is what? Rectangular, from the model that you just saw, rectangular model for the column. And then on this page that says concrete type, I will come here and choose what? Normal concrete, not light concrete. Normal concrete is used for reinforced concrete design, and knowing that all buildings are to be what? Are to be reinforced concrete, so we then choose what? Normal concrete. And then we have already done everything here for the spacing, except this one that says what? Spacing between pies, which we are going to do this checking after we are done with our design of what? Of our pie caps. Okay, I know that. Let's now move on to the material selection. Okay, now on this place now, this would have to tell you what? The concrete grade you have to use. Since it is foundation, I'm going to use what? Concrete grade of what? 20 or 25 for the, so I'll just come down and choose what? Concrete grade of what? 20. FC U is what? 20. And then for the lengths, okay, for the, sorry, let's go for the steel bar. For the steel bar grade, okay, I want to use 460 for my steel bar. Okay, let me just use 14. It's okay for 14. And then I'll come now and then choose what? Links rebar. I will then come here. You can see that I have several rebars here. I will then come and choose something as what? 14. Then for the diameter right now, I'll try Y16 to see if that's okay and all that. Then for the links, I like to use what? Diameter 10 for my links. Okay, not 8 but 10. Now once you're done inputting all these values now, as you can see, the next thing now is to now provide the design data sheet that you're going to use to impute in the software Protastructure. Okay, so right now let's now go and impute and click on this place now. If I click on this place now, it will give me what I am meant to impute on the software Protastructure. So you can see that this is now PileSoft design data sheet. If you then go here, right, this is now the output. Okay, as you can see, it also gives you your drawing for the number of pies that you are meant to use. Okay, here it says number of pies is 6 number of pies. That's what is required. Okay, and all that. So let's now check out for that, and then so you can now see that here now that this is now the design output data. It is this software now, it is these values now we are now then going to do use or export to the Protastructure based on that column which we are designing for, which we took the value of the column load. Okay, but apart from column load, every other things here remains the same as long as you are using the same pie diameter or the pie size. Okay, it remains the same. Okay, so right now let's now go and now input these settings into the Protastructure setting center for pie cap design. Okay, that's fine. Now on this place now, don't forget that the column load we took was for this column 20. Okay, but let's now go and impute the values on the setting center, because anything we impute here on the foundation here, pie cap, on this place here is what we are going to use for all the pie for all the pie cap design for each of the column. The only thing that will be changing is the column load. That is what will be changing. Okay, because the column load is what they will use to determine the pie cap reinforcements and all that. Okay, that's fine. So with this now, let's now begin to impute the value now that we got from from the PileSoft. Okay, so I just wanted to share my screen like this now, so that it can be easier for us to impute the values. Okay, so with this now, this is now for the PileSoft, and this is now the values we are going to impute into Protastructure on this place. So first, let's now begin. The first value we have here on the options for on our Protastructure is is the ultimate compression capacity, and this value can only be you can only get this value when you have your safe working load. I can see that we imputed the safe working load into this PileSoft here. Now on this place now, let's now look at for what the PileSoft gave us as the ultimate compression capacity. You can confirm that by yourself if you know how to confirm the ultimate this value using your safe working load. Okay, so right now you can see that we have 1110.2. So we then come and put 1110.2. So you can for all the advanced engineers here watching this video, you can drop your comment section if you find anything I'm doing here that's not correct. Drop it down on the comment section, and then I can be able to explain to you guys. But if it is if everything I've done here is correct, I also like you to do comment down on the comment section, that also the younger engineers can be able to do also learn from you guys. Okay, that's fine. So with this now, I will then go and then do what again? What is the next thing here? The ultimate tension capacity. But basically the way I follow it is that I like to follow from the first one here down to the last here. Okay, so let us start from the first. Okay, so from the first now, from the first here, you can see that the first thing we have here is which we have put this here. Okay, there is nowhere for us to impute our number of pies here, which you can see that number of pies. So let us start with this first. We are seeing here first. We have done this now. The next now is what? Ultimate what? Tension capacity, which you are seeing here, and is what? Is 370.1. So come now here and put what? 370.1. That's fine. And then the next now is what? The default pi length. The default pi length that we used on our displays here was what? Was 24 meters. Don't get that wrong. So let us go back right now on that place. You'll be able to see it right now. So if I click on this back now, you'll be able to see that the default value that we have here is what? Is 24. Let me just extend this a bit. You can see that right there is 24 meters. Okay, this is here 24 meters. So I'll come now and put here what? 24 meters. Okay, that's fine. 24 meters. Okay, then we then go back to our touch again right now. Okay, so on this place now, just go here. The next thing now we'll have to input here is what? Is the multiplying factor between pi's, which you can see it says what's here, use factor to be what? 2.5. So I come now and put in what? 2.5 and then 2.5. Okay, that's fine. So then the next thing now I'll then input right now is to do what? We have to what? We have to input what? Distance to face. But before then, let us finish up this place here. This says what? The shaft type is what? Circular. If you can remember, circular we used. And then penetration we used to be what? 75. As you can see that. So it's here 75 here, 75 here too. And then the pi size, which is the pi diameter, it's a use pi size is what? 450. Is that? So then come now and put here 450 here. That's fine. And then the next thing now we'll then do is to do what? Is to now what is this again? Okay, we then have what? Distance to face here, which is saying use 150 or 200 or 250 for what? Distance to what? To face. Okay, so we come now here now and then put what? We can use 150 actually or 200, but I like to use 200 actually. 200 and then 200 as my distance to face. Okay, between the pi cap and the pi. Okay, that's fine. Then we then come now and do what? Number of pi's. Okay, now for me, I like to do what? I like to use here to be what? Minimum to be what? 1, and maximum 100 is too much. I like to use maximum to be what? To be, let me just say 10 at maximum. Yeah, 10 at maximum. Then leave every other thing here as default. Next thing here, come here and come to do what? Concrete cover. Okay, now on this place you can see that cover of concrete we use what to be what? 50. As you can see that before 50 we used. So I'll come now and then say 50, but I say that you should try to be using what? 75. That's more safer. So 50 and then 50. Okay, and that's fine. So then since we have now inputted all the values that we have here into this place, which is the PileSoft here, then we then come now, we are left with what? Pi cap depth. Okay, pi cap depth, which is here. You can see that from the PileSoft here, they say what you should do what? Minimum is what? 1100. So come here and put 1100, and the maximum is what? Maximum is what? 1300. Although that's based on the load of the pi. Sorry, oh yeah, of the column load. Okay, but right now our advice is just put the maximum here, although it can still be changed later. Okay, but let me just choose maximum to be what? 1800. Okay, and all that, but based on the column load for the which we used here is given to be what? 1300. Okay, but just put higher one. Okay, because we are going to design for each of the column. Okay, that's fine. So with this now, I'll then come now and then say okay. Okay, that's fine. So we have now entered into the main pi foundation design. But before we do that, let me now do what? Save. So we have just applied a general settings into this Protastructure, which we got from what? From the PileSoft. Okay, now you will now see how our pi foundation now will be very easy. Okay, and all that. Okay, that's fine. So with this now, I'll then let me just maximize this again right now. Maximize this now, and then come now and click on this place here and right click here and do what? Say again now pi cap design instead pi cap. Okay, now let's just hold on for that. Now on this you can now see that it has now reduced. Can you see that? Before, it was giving us a very high number of what value, okay, number of pies. Okay, so right now let's now begin to do what, impute the remaining values which was not in the software Protastructure. Okay, so right now that we have now imputed this value, let's now go and look at our what column load again. You can see that our column load now has now reduced. So this is now the actual column load. Okay, this is now the actual column load. Before, it increased because the size of the pie cap was big, so the pie cap was much and everything. So it now this is now the actual column load 2299. Okay, so let's now go and impute this value now into the PileSoft to now design only for this column. Okay, that's fine. So on this now, we will then go back now, just click on back here on the PileSoft, and then impute our column load now, which is what, 22990. Okay, so we then come now and then put our what, the value for the column load of that 2299.0. Okay, that's fine. So with this now, this is now the actual column load. Every other thing here remains the same because that's what we got from the soil report. So the only thing now that we will be changing is just the column load. Okay, that's fine. So we then come now and then click on the place there that says what, design what, data sheets. Okay, that's fine. We then go over to our what, summary here, which is the output. You can see that it says what, number of pi is what, 6. Okay, that's fine. So we then come now to our PileSoft and begin to now insert all what we got from our PileSoft into the Protastructure. Okay, that's fine. So with this now, I'll then minimize now and go and look at for what I have on the PileSoft sheet. Okay, so the PileSoft now is saying that based on the column load and everything, save working load, everything, we have what, 6 number of pies for that particular column load. And then we also have what, the design use what, 1100 millimeter or 1.2 or 1.3 as my pie cap depth. Okay, now let's now go and impute these two values now into the Protastructure. Okay, that's fine. So with this now, I'll then come here, open this up, and then come now and impute this number of pies is what, 6. Now I said again, this software tends to do what, perform over design and also under design too. So you must have to make sure you understand what you're doing first. So with this now it makes it easier because we have already gotten all the values. Okay, now for the pie cap depth, which we got from the PileSoft, they say we can try 1100, 1200 and 1300. Okay, so 1100 now is failing. Okay, let's now go and try what, 1200. Okay, now and see, it's still failing. Now let's try 1300. Okay, and yeah, that's fine. This one now is now okay, it's passing. Okay, and then from the PileSoft, the shaft type is circular, which you have done before. Circular penetration is what, 75, done before. The pie diameter is what, 450, as you can see from the PileSoft here. Okay, pie size 450. This other one here is what, 75 penetration. The pie shaft circular. We now enter into the for the use spacing for the spacing factor, okay, which is 2.5, and then they say we should use 150, 200 or 250 for the what, distance to face. Let's go and impute these two values now. Okay, so on this place now, they say we should use what, 2.5. Yes, that's okay, 2.5 for the spacing. Okay, that would have. Now they say we can use here 150 or 200 or 250. Okay, now whatever value you are putting here will impact on this place. Now this value, what governs or controls this value is if your pie cap is resting on the ground or not, as you can see from the PileSoft how we got that value. Okay, now they gave us 3 options: 150, 200 or 250. Okay, now any value you put here we have impact on your pie cap dimension. If I reduce this now to 150, okay, and here you can see and here 150, you can see that it has impact. It has reduced from 1,000, from 3,100 to 3,000, and here to from 2,000 to 1,800, so to 19. If I put now 250 here, it also have impact by increasing it 250. Can you see that? So you have to make sure you choose. You can choose directly from the three options given to you. It's perfectly okay. So let me choose 150 now instead of using the higher one. 150 that was given to me from the option 150. Okay, so at least I will have a lesser pi diameter pi cap size. Okay, that's fine. Then for the pi capacity now, which is the ultimate capacity, and for the pi capacity, which is the compression and tension, to get this now, let's now go over to our PileSoft. Okay, and on the PileSoft, we got this value when we inputted our safe working load. We are able to get these two values. Okay, now we can see that we have 1110.2 and 370.1 as the tension, and that which we have already inputted before. If you can remember, we inputted these two values before, base, because that was a column load we used, and all that. Okay, so this safe working load now is constant as long as we are using a bearing a pi diameter of 450 for the design of that pi cap on that column. It remains constant because what governs this pi capacity is the safe working load, and the safe working load is being gotten based each of the pi diameter. So each of the pi diameter has their own safe working load, as you saw on the soil report. Okay, that's fine. So for now, since we are using 450 as our pi diameter or pi size, we will have the same ultimate compression and then tension value. Okay, on this. Okay, that's fine. Then this is rectangle. If everything is now remain the same, as you can see, they will now come now and do come here now. The next thing now, go to our PileSoft again now. From the PileSoft now, we have now inputted these two values now. The next thing we have is to do pi cap is designed horizontally. That is in direction 1. Okay, so we have to make sure that it is in direction 1, and that is gotten by from this place here, which is the direction 1, which is on options here. Let me see. Yes, correct. This place here. This is direction 1 and direction 2. If I click on this now, it will turn. Can you see that? But instead you should design on direction 1. I'll tell you when to change your direction, because if you change direction, it will change the input values. Okay, I know that. Okay, that's fine. So with this now, I will then come now and then move on to PileSoft again. PileSoft, let's see again. Let's see. Okay, so we are done with this now. We are now entered into these two last one here that says internal bending radius. Most people don't understand this at all. Now, these two values is very, very necessary and important when it comes to pi cap design. Now, the reason why it is important is because on this place here, from your software here, you can do your pi design, and here can be showing everything green, so successful. That's fine. But when you come to design checks here, you see that you'll be having issues here on this bending stress. Here will be showing red. So even if here is showing red, here can still be showing design successful. But what it means is that your pi cap design is not correct. You're still having warning. Okay, because for you to have it successful, you must not just put your eye, because even if you're here, you will see that everything here is okay. You must come to design check here and make sure that everything here is sufficient and okay. So on the other column design we will be doing, you will see the effect on this place. Okay, so right now we are going to put the values, okay, that we got from this PileSoft here, from this PileSoft, okay, into the software Protastructure, and that can be gotten from from us going back to this software here, and to see where to input that value, you will get it from this place here that says rebars. Okay, now on this rebars now, you can see here that says internal bending radius. Okay, now on this place now, this internal bending radius will be governed based on the diameter of rebar you are choosing. Now, basically, you must strive to do what? To reduce cost when you're doing what? Designing for any structure. So with that, I'll try what? Diameter what? 16 of our what? Reinforcement. Don't forget that that's what we chose when we are on our PileSoft. Let's just go back now. Right now, on the PileSoft now, we chose what? Let me just go back right now. Let me just go backward. Back. We chose what? Diameter 16. If you can see that, okay? That's the minimum we chose. We just assume first, okay? So let's now go and choose what? Diameter 16, okay? On the Protastructure, which is here. Now, if we choose these two now, and then come here again here and choose this, okay? That's fine, 16. You can see now that it is failing, okay? It is not failing, okay? You can see that it's failing. And from our checks here too, our checks here is okay, but from the design itself here, you can see that it is failing here. It is failing here. Now let's just try if we can use that value now to now correct that. Let's now check that for that, which is on these two places here, okay? Now let us input the two values now which we got. Let us see that right now. Come here, PileSoft, that's fine. And then you will then see that on the internal radius, they say we should use what? Minimum for x direction 64 or 130 at maximum, and for y direction 64. Okay, let's now put in those two values now. Back to this place now, and then you will see that let's now put, the first one here is x, the last one here is y. Okay, so they say we should put what? Minimum of what? 64 and 130. Our advice to what? Do the maximum, which is 130 for the x direction, and then here we should do what? 64. Okay, that's fine. 64, that's fine. Now you can see that it is still failing here. Now let's just now go and do what? Reduce our spacing from 250 to what? Let's try what? 200. Okay, and see 200 now. 200 spacing. Okay, that's fine. And then here also 200 spacing. That's fine. Okay, so you can now see that we have now reduced from 20 diameter before that was given to us on the software to what? To 16. Okay, and then you now check now, since we have now inputted all the values now that we got from the PileSoft here. You can see all the values now, and after the values comes what? Comes the drawing detail. You can see that right now. You can see that, which you can also print out later. You can print out your report and then attach with your Protastructure report, okay, and everything. Okay, so you can see right now that we are done with this. The next thing now, back to our software now, Protastructure now, which will now have this, so we can now check everything again. Everything is okay, everything is okay, everything is okay. We can then come now and say, then we can call this one, call this name PileCap what? This is 6 number PileCap what? 6. Okay, and then which is PileCap type 6. Okay, and then let me just say PileCap type 6. Okay, PileCap type 6. Yeah, that's okay. Type 6 or T6. Let me just say type 6. Okay, type 6. Okay, that's fine. So with this now, I'll then come now and say okay first before I generate my water report. I'll say okay first. Now on okay now, let's just hold on for that. You can now see our PileCap now is now perfectly designed. I can then go ahead and go and generate my report, but I'll do that later when I'm done with all the PileCaps. I'll then generate my report based on the grouping, how I have grouped them. Okay, that's fine. Let's now go and design for the next PileCap now, which is, let's also choose this other one here, column here, which is column 12. I'll then click on this place now, right click now. Now this first one we did was a bit longer because I was trying to explain everything. Right now we'll just pick up the column load here and then move on to the design of the value. Okay, that's fine. So then come now and do what? PileCap here. That's okay. And then do the same thing here again right now by coming here now. Just hold on, go back now, go back here, and then come now and just come to our column load here and pick our column load, which says what? 1756.4. okay, 1756.4. go to our PileSoft now, and impute the value of that column load. So just say back here, back, and just the column load you need. Come here, 1756.4. That's fine. And then come now and do what? Click on what? Dash it here, design. Okay, and then you will get, you can see that now it says what? The number of pies, what? 4 number of pies. Okay, 4 number of pies. That's fine. So 4 number of pies, and everything here, we just input all these values now. The only thing that changed there is this, and this, yeah, just this one here that changed, which is the number of pi, because everything here remains constant because of it, because the pi diameter has not changed, and since it does not change, we still have the same safe working load and then the same pi capacity, okay, based on the safe working load and everything here. And since we didn't change the diameter of bar, that means here remain the same. So let us just go and change this one now and see if 4 number of pi cap can be able to pass that, and also design and also check for the pi cap depth. We have the three numbers here. That's fine. And then go now and go and confirm it again. So we have what? Number of pies, what? 4. So come here and put now 4 number of pies, okay? And then we have what? Different pi caps, 1.1, 1.2, and maximum 1.3. So 1.1 now is okay. As you can see, everything is okay here. It's okay here. Let's go now do for what? For the checks here, okay? Then let's go for rebars first and change. I don't know why it's using Y16, Y16, and then here is also what? Y16. Let's see. Okay, if everything passing here correctly, that's fine, and everything here is okay, that's fine. We then come back to rebar here and put our value from the PileSoft, which is the internal bed radius, was here 130 and here 64. We got that from the PileSoft, as you can see, which is gotten from this place here under PileSoft here. This is 2 values I just inputted right now, these 2 values here. Okay, that's fine. Then come back now to the Protastructure here, and then come now, everything's okay, and then come now and come here and say what? Pi cap type what? Type sorry, cap lock type what? Sorry, that's a type type 4, because it have four numbers, okay? And then come now and do what? Say okay now. That's fine. You can see that. So this is the way we design for what? For Pi Foundation, okay? The same way. Let me just turn off my grid lines. I don't like the way it is playing. Okay, it's making it look dirty. Okay, that should turn off here. That's fine. Okay, so you can see what I'm doing right now. You can see that what I'm doing right now. Okay, so then I'll then go again right now, and then let's design for this other one here. I'll do just one again, and then the same steps goes for all. Okay, I'll then let me just do it for this other one or this other one here, or let me just say okay, this other one here, yeah, this other one here. Let's check this out now. So with this now, I'll then come now, right click now, and do what? Insert pi cap, and then come now, sorry, just minimize this, come back to this other one here first, then come to column load here and pick your column load. We have 2345.7, 2359.7, sorry, 2359.7, that's correct. So I'll come now back here and input the value for column load 2359.7, and then come now and click on what? Design data here. Okay, I have what? 6 numbers. Okay, 6 numbers. So I'll come now back to the place again here, Prota here, and make sure you can see that this software Prota basically perform on the design a lot, and most times over design too. So I'll come now and then put here, choose what? Here to be what? 6 numbers, and then come now and impute my, I have different depth of 1 1 1 2 1 3. Let me try 1 2 now. If it's okay, 1 2 is okay, it's failing, so I try 1 3 now. 1 3 should pass. Okay, that's fine. So I'll then come again right now and check everything again, and come to this place now, design checks, everything is okay, and come here right now and then confirm this here, change this to what? 16 diameter, 16 diameter, and choose a good spacing. Let me say 200. 220 is not okay, and then 200 also. Okay, that's fine. It is fading here, so I'll come now and then try let's say 250. It will not pass, it's fading. So right now let's try 200 is not passing. Let's try 175. Okay, and then yeah, 175. It is too close a bit. You can see this base reinforcement there is too close for the share. I know that, so I'll try to use let me try to use 150, and then here 150. Okay, that's fine. The top basically does not have any issue. For the sidebars, I can choose 12. Okay, 12 is not here. Okay, I can add 12 and then choose 12, but for now let me just leave it to the way it is. But I can change that to be what? To be 250, and then 250 for the sidebar to use lesser bars. And for the top bars, doesn't have any issue. I can choose, I can leave it to be 250, or 250 is okay, 250, and then 250 also. Okay, yeah. So what is carrying the load first is the button here. That's why you can see that the base reinforcement here is having lower spacing. Okay, that's fine. So with this now, check again, and then final check here. That's fine. Okay, and this still falls under what? 6 number of what? Pi caps. So this is still under what? Pi cap what? Type what? Type sorry, type 6. Okay, that's fine. And I'll come now and say what? Okay here, that's fine. Okay, that's fine. You can see that? That's okay. So with this now, so if I want to turn this now the other way around, I'll just yeah, let me, if I turn it now, it might begin to have issues on spacing with this, because here right now, if I do this other one right here right now, by doing this other design here, pi cap, okay, and pick the column load now into the PileSoft, go to column load now, just minimize this, come now, open the portal again, come here right now and pick up the column load here. This is what, okay, they have the same thing. This is what? 2365.9. They will basically have the same number of pies, okay, which is 6, because this is 2365.9. okay, 2365.9, and then back to PileSoft now, back to PileSoft. Okay, sorry for that. Okay, back to the PileSoft now again. We will then come now and go to backspace, back here, and impute the value 2365.9, 2365.9, sorry, 0.9, and then come back to this place here, okay, and design the pi cap, sorry, and we got what? 6 number of pies. Yes, they will be the same because they have the same what? The same almost the same load is going to that place. So we'll come now and here, okay, and pi here, and then come here and put what? 6 number here. So you can verify, then put the diameter here for the depth for the pi. 1300 is the maximum we have from our PileSoft, okay, and everything looks okay. Then come to our rebars now, reduce the rebars to 16 and see if that will be okay. 16 again, and then 16, and then come here 200. Okay, it's not working already, so let's try again. 175, let's see if that will work, and 175 here, 175, and let's see. Okay, that's fine, that's okay. 175 is okay, yeah. And come to checks now, everything here looks okay on checks, that's okay. Then come now and then group it again under group type what? Type 6, okay, that's fine. But basically, if you're going to group your column for your pi cap, you have to use the same spacing, okay, for each group, the same spacing, don't change it, okay. So we used last time 150, so I'm to use 150 again because I'm taking it as one group, except you don't want to group it, and that will help you during detailing. It will have you to have less join, okay. So let me just group now to 150 and all that, but 175 is okay actually for this, but let me just say 175 as it is, just to save cost of the number of bars to use, okay, that's fine. So right now then come and do what? Come back here and then say type 6 or type 6 6A, that means that it's 68. That's one is using 150 spacing of bar, one is using 175. Okay, that's fine. And then come and do what? Say okay here. That's fine. So with this now, you can see now it's now okay here. That's fine. So you can let's now design for an edge, for edge one, for the one that has an edge. Okay, you can design basically for this one as a combine. Okay, you can design for this as a combine, which is the wall and the column. Okay, that's fine. To design for a combined pie, for like column, what we'll do right now is to do what? Highlight this place. I can see that we'll have wall here, another wall, and then column. Okay, so with this we have to design them as one pie, under one pie cap. So with that, we then do what? Highlight this and then right click on this and then come here and do what? Say insert combine pie cap. Okay, and then it will display. Now we'll just pick up the column load, and with the help of PileSoft we will be able to now design for that. Okay, then minimize this again right now and then go back to this place and pick up the column load here. Okay, now you can see that it is giving us as what? As 3 number of pies. That's why I say that basically if you don't know how to use Protastructure very well, it's advisable you do what? You use PileSoft together with the software Protastructure for your design. Okay, that's fine. So with this now, I will then come now and then impute, come to column load now and then copy this column load here that says what? You can see there 3240.3 3240.3. Then come now, minimize and then go to my PileSoft here, PileSoft. Okay, and impute the value. Go back first, 3240.3. Go back right now and then come now and put in the value here 3240 point what? 0.3. Okay, 0.3. That's fine. And then come down 3240.3. That's fine. And then come down and then click on what? Design here, and we now get all our value from here. This gives us what number of pies? What? 8 number of pies. Okay, 8 number of pies. That's fine. So we then come now and then come to this place here now and come here, pie here, and then come here and choose what? 8 number of pies. Okay, because if you confirm it now from the PileSoft here, the PileSoft gives us to be what? To be what? 8 number of pies from our drawing. Can you see that? 8 number of pies. Okay, that's fine. So with this now, we then go and then begin to then also let's see now the stuffs we have here. Let's see this place now. Okay, let's see the depth we have. We have 1 1 1 2 and 1 3 as our depth, but I am afraid the 450 diameter of pie will not be able to be sufficient, so we have to go and choose a different diameter of pie from the soil report, and that will change our what? Our safe working load also, which will change our compression, which is our pie capacity also change. So 1 3 right, let's see 1 3 right now if that will work at all. Okay, that's fine. So 1 3 basically worked out. Okay, so let's just see again right now. Let's see again now, and let's see. Okay, let's now see for the checking here. Okay, and then for the rebars, let's see here right now, and then come here and do what? Let's try 16. I am afraid that will pass, but let's just try that and see. 16, let's see. Okay, let's just try and now reduce, because it's failing here. Reduce the 175. Let's see. Sorry, 175. Let's see. That's okay, perfectly okay. Let's try 200. Let's see if that's okay. 200. Okay, that's fine. It's okay. 200 is cool. That's fine. Okay, that's okay. So right now, then check again here. That's fine. So you can see that basically this software gave us 3 number of pies only, and if you're not good enough, you accept it that way, and that will give you a block, a collapse. Okay, that's bad. Okay, so right now let's now go and do what? Come here right now and do what? Pie cap what? Type what? Type 8. Type what? Sorry, type 8. That's fine. And then come here right now and do what? Say okay here. Okay, that's fine. Okay, that's okay. So you can now see how it is now. So you can see how it is now. That's fine. So you can now see how we have designed. So the same step, you will use the same step now to design for all the columns that you have here. Okay, the same step you use to design for all the columns that you are seeing here. Okay, so I will stop this for now, because if I continue, it will make this video to very long. Okay, and most people might not like it because it's long, but the same step, you have seen the step I'm using right now. Once you put everything, just take your column load into the PileSoft, and it will give you your values, your values for your design in this software. Now, PileSoft is the best I can advise everyone using this software to use. Else, you'll be having issues on the design of Pile Foundation in this software, Protastructure. Okay. Now, if you want the PileSoft, you can get it directly from the PileSoft company, which is the GeoExpert, or we are the subsidiary of GeoExpert. You can get it from Ekidel directly using the link down below. You can get it from the link down below. And if you have any issue regarding the software, knowing that you purchase it from Ekidel or from GeoExpert, which is the PileSoft company, they can be able to resolve your issue as long as you purchase directly from GeoExpert and from the GeoExpert, which is the PileSoft, or from Ekidel directly. If you purchase from any other place, by the time we verify your email address and your address, your purchase is not on the list of GeoExpert or Ekidel, we are not going to help you out if you have any issues on the software. Okay, that's fine. So if you want to get the software PileSoft, check the link down below, or check on our bio and go to Ekidel online store, and you'll be able to get that software from there and all that. Okay, thank you so much. Now, it is not free and it's not that expensive, but it will help you a lot when you're doing your design on your Pile Foundation. Thank you so much, and God bless you. If you like this video, please, I would like you to share to your friends and colleagues, and also give this video a thumbs up, and also subscribe to our channel if you're new on Ekidel. So bye for now, and see you again by this time next week. Okay, bye then for now. Okay then, bye.